is actually very simple. The stuff that we're going to walk through here is start out with is a little bit of review. It's what we call function notation, f of x, g of x, things like that. This function notation looks like this. F of x, g of x, it just means there's some function 2x, there's some function x minus 3. What we're going to do here is work with function notation where it looks like this then. What is f of 6? What is g of 7? What is f of shoot? So what happens here is this is nothing more than direct substitution. When I'm looking at that first where I say, what is f of 6? Which equation do you think I'm talking about? The f or the g? The f. What I'm doing here is I'm going to replace the 6 with the x. It's substituting it. It's telling you what to put in for x. So you get 2 times 6, otherwise known as 12. All right. When I say g of 7, you have to figure out which equation to work with. Is it the f or is it the g? G is, you're right. And then you're substituting in whatever's in that parenthesis. I may feel like crap, I still have some humor. Whatever's in that parenthesis, you are literally substituting in for x. I didn't hear it, so I can't hear anything anyway. What is 7 minus 3?
4.
Yeah, 4. Now, what is f of shoe?
2 shoes.
There's no s on that, it's just 2 shoe.
2 shoe. Yeah, you should make it shade instead of. What are you coming down with?
Bowl.
Organic. A bowl of what?
Alright. So you wind up, it's, like I said guys, it is absolutely, it's the heart problem. Remember that from similarity?
No.
You love the similar thing, you just draw a heart around to get your ratios?
Oh.
What? It makes sense, but we never learned it.
Alright, so what we're going to do here, don't write this out. What we're doing here is we're going to create new functions given f of x and g of x. Composite functions. Composite functions are just functions made up of more than one function. Hence the word composite. Okay? It's literally substitution and combinable terms. For example, if f of x and g of x are 2x and x plus 1, it would be 2x plus x plus 1, otherwise known as. So, it is, we're going to be working with that. Some of the multiplying and working through things, you'll have to worry about your exponent rules again as well. It's not going to be as heavy with some of those as it has been in the past, or the past few days. You should be pleasantly surprised at how easy this really is. But, let me get to the weirdness. Well, we'll get to the weirdness in a second. So, let's take a look at this. Just to walk you through how it's going to look when you have exponent rules.
Can you write this?
Probably. You get a better idea, yeah. Now, when I'm talking about adding or subtracting, my two functions are f of x is 2x to the half and negative 6x to the half. And it's asking me, what is f of x plus g of x? The only difference between what we're doing today with some of these problems versus what you did last week is that you have to write down the problem before you can start. Last week they gave you something to start with. Here you have to do this. You have to actually write it down to start. Can you combine those right off the bat? What's 2 plus negative 6? Because you're just combining like terms. Same base, same exponent. Just go through it like that. You don't have to do anything else. All right. But
Will we have problems with this, like, it gives you HVAC, C
just start, right?
Okay. Okay.
But yeah, you will have to do some, it's mainly when you're multiplying and dividing. And it's, you'll find out it's really simple. Okay, you're still using the same thing. Does everybody see how the only difference between what you did last week, which was starting here, is that we're starting here? We took one step back to take 2 steps forward. Alright. So the other one would be 2x to the half minus a negative 6x to the half. And what do you get there? Good. That's usually where people screw up. You forget the negatives and stuff. Okay. Like I said, it's not horribly scary math. All right. Well, not yet. The weirdness comes in when we start to talk about composites. When we start talking about actual composite of the functions. And those look a little bit different. If I want to look at, we'll do this one first, sorry. I forgot this was next. Let's look at, Clay, you were asking about multiplying and dividing. If I'm looking at multiplying and dividing, it's going to be the same stuff like it was last week. It's just telling you f of x times g of x. So you have to write them down first. So it's a lot like copying the problem from the book, but it's making you have to look someplace else. I don't know how to explain it differently. So you just wind up with 3x times x to the 4th. Everybody okay if I took care of numbers first there? You just get 3. And then what's x times x to the 4th?
X to the 5.
That's it. That's it. Okay. Same base, different exponents. Just add your exponents to your multiply. And when you write it out via division, 3x over x to the 4th, you fall back into the idea of playing war. Who's going to win? X or the x to the 4th? Did you say the union? Well, congratulations for winning. You saved us. Yeah. So the 1 in the numerator for x to the 1st power would win. So what's 1 minus a quarter? Exactly. And you just wind up simplifying it out. And notice how the problem started with a fractional exponent. Just finish it. Okay. Exactly. We okay so far? What's that? Yeah. A little bit.
When's the quiz?
The composite is where things get a little bit. The composite's usually where people start to get a little fuzzy with it. Now, composite functions is a combination of 2 of them. Let me go back to a real easy scenario. So we had f of x was 2x, and our g of x, what did we have earlier, x minus 3? And a composite function looks a little bit differently. It looks like this. What is f of g of x?
Well, that's what I encountered on the practical execution.
Yes, you see this a lot. This is a lot of this composite function stuff is all over the ACTs. It's on there a lot. You see this quite often. You might even see it written out with triangles. It's kind of weird. I'll find the problem that does that. What this is telling you to do is take literally the g of x equation and substitute it in for x in the f equation. So here's how I always write these out. The innermost parenthesis is g of x. You agree? Write it down. Now surround it with the f equation. What I mean by surrounded by the f equation is the f equation says 2 times x, right? Well, this is the new x. Distribute. Okay? And you just distribute. And there's f of g of x. Going the other way. G of f of x. Because I'm taking this and I'm substituting it in for x. Okay? Remember what we did f of
So
6?
the G is the X.
Yes. G of f of x. I'm going to write down the f of x equation first. And then I surround it with g of x. Well, the g of x equation is just x minus 3. It's exactly right. It's just 2x minus 3. Because the x value is now 2x. It's a composite function. Yes, sir?
So it's like the definition of composite, like, is it just used in this case, or is it in everything?
We can do composite functions in everything if you like. We actually use composite functions to show inverses, and that's the second part of what we're getting to today. I wanted to get you accustomed to the nomenclature to see how it's going to work. Yeah, Shannon?
I'm still okay. So I'm still kind of like fuzzy on how you like why it's 2x minus 3 instead of like 2x squared minus 3 or something like that. Because it's like,
I'm taking this value, I'm substituting it in for x. What is f of x? It's 2x. 2x minus 3. It is literal.
Oh, okay.
It is literal taking one thing and putting it in for the other.
Right.
Remember we did f of shoe? It was 2 shoe. Same idea.
So G of X, the first one was substituting for X.
What about f of x? It is weird. Exactly. You write down your f of x equation, and you surround it with what's left times 2, like you said, Zach, 4x. It is kind of fancy, isn't it? All right. Composite functions will allow us to find inverses and verify that things are inverses, and we talked about that in 7.4. So let me show you this with not just linear style, but with some of the negative exponents. It works the same exact way. So if I'm looking at excuse me, if I have f of x is 3x to the negative 1, and g of x is 2x minus 1, I'm going to find f of g of x, g of f of x, and f of x. Because it's fun. We can do g of x if you want. You know what? Let's do that instead of f of x.
Yeah.
We'll do g, because I've done f of all day. We'll do g of x.
Yeah, do you the values up there?
Sorry, I was writing so I can see it. All right. So when we start these out, it's just like order of operations. You're going to the innermost parentheses. The innermost parenthesis is g of x, so you write it down. And now I surround that with f. I substitute in 2x minus 1, that term, into the x value in the f equation. So now I got junk to the negative 1 power. Is that junk happy?
No. Sad.
Send it to where it's happy.
Sad.
The junk is sad. There you are. And there's nothing left you can do. There's no other simplifying you can do with that, because there's a subtraction symbol. Okay. Not bad. All right. G of f of x. Going the other way.
Where's there in the top?
Because it's not raised to the negative 1 power. The only thing that's raised to the negative 1 power is the value of x.
Oh.
If it was 3 to the negative 1, this would have had to have been in parentheses. Does that make sense? So, start with the f of x equation. And I surround it now with the g of x. So 3x to the negative 1 is being multiplied by 2 and subtracting 1. So, what's being raised to the negative 1 power? It's just the x, remember? Just the x has it. It's just like Lydia was just asking. Notice up here, the only thing that has the negative 1 power is the x. Otherwise, you would have seen, oops,
Oh no.
Otherwise, you would have seen parentheses around all of it. So the only value that had the negative is just the x. So the only thing that's not happy is the x. So what's 2 times 3? So it's 6 over x minus 1. And you're done. All right, go ahead.
Yeah, wait, why
Oh, no.
Free conversation.
I always wanted to say 5 over.
Can't, because it doesn't have a common denominator. The only thing that's, the 1 is tacked on the outside. It's not part of the fraction. Right. Now, g of x, same idea. We take the g equation, which was 2x minus 1, and we surround it with 2 and a minus 1. What do you get? 4x minus 3. Not scary and open? So take a minute, find those.
Wait, for some reason, get x minus
This is going to be 4x over x minus 1. Can you do anything?
No. For 7, is it x minus 1?
It's not cheating. How's that cheating?
I feel like it means you have to do something.
No, that's okay. Is 7x minus 1?
7? No, it's 4x squared minus 4x. No, you can factor out, but you're just telling you to multiply them together, so you don't have to factor anything out, because when you factor it out, you started right back where you were at.
Oh, yeah. This goes to x minus 1.
All right, so let me show you what this means then. With f of x and g of x can be used to find inverses of functions.
Is this the first time you did words in math class?
Yeah, I have to do it also now. So what we can do here is we can use these this symbols, this symbolic, whatever, symbol, whatever. F of x and g of x. F of x and g of x can be written out in a manner to show that functions are inverses of one another. And that's kind of what we're going to get into more tomorrow. But I'm going to bring in the part with the f of x and g of x part today because it blends real nicely. Because function notation is really quite simple, and I have 20 minutes. So let me show you this. F of x and g of x can be inverses if and only if this happens. F g of x, let me write this out. F of x and g of x are inverses if and only if. Remember that?
Yeah.
All right. If these two things happen, if f of g of x, when you substitute those together, and you get x, and g of f of x also equals x. If those two things occur, then they're inverses of one another. Yes, sir?
What is an inverse function again?
An inverse function is going to be one, I want to say opposite. It's like the opposite of the function.
So it goes horizontal?
Yeah. We're going to get more into the actual graphing of how it actually works tomorrow. I just want to do this part today because the algebra is very easy. Okay. So when I'm looking at the inverse here, let me give you an example. Where is it? This. Not here. If I want to show that, say f of x is 1/2 x plus 1, and g of x is 2x minus 2. I want to show that those two are inverses of one another.
Wait, is that the only if?
Yeah. That's the only thing that happens. And you, basically, you're doing the f of g of x and g of f of x. You do 2 steps just to see if it works. So all I'm going to do here is I'm going to check, does f of g of x equal x and g of f of x. And like I was saying earlier, it's a lot of direct substitution. So if I start this, f of g of x, I write down the g of x equation. You okay with that? And I surround it with the f equation. So g of x is 2x minus 2. To that, I have to surround it with 1/2 plus 1. Because remember, I'm taking g of x and I'm substituting in for x. Are you okay with that? What's half of 2?
1.
What's half of negative 2? What's x minus 1 plus 1?
Wow. So simple. Okay, we're half right.
We're halfway there. Do the same thing. G of f of x. Write down the f of x equation. 1/2 x plus 1 surrounded by the g equation. What's 2 times 1/2? 1. What's 2 times 1? So you have x plus 2 minus 2, which is? Therefore, these guys are inverses of one another. You didn't distribute the 2 to the 1. You gotta remember to send it to both parts. That means those 2 equations are inverses of one another. Okay? They're inverses of each other. Not so bad?
Not so bad.
All right.
Okay, my spelling is
Okay. It should be all right.
No. It's growling.
So, what about this? What changes?
No, it's actually
Nothing.
Yeah.
Nothing changes. We're going to check to see if these guys are inverses of one another. You just have to verify. It just takes a little bit longer to verify because you have to go through some of your exponent rules. Right? You could think if you got to write it down. So I'm going to start with the f of g of x. So I write down the g of x equation, which is okay, and I'm substituting that into x in the f equation. So I surround it now with the f. It is weird, but it's not that difficult. What's the first? In this case, you have to go, please excuse my dear salad. Well, in the parentheses, there's nothing I can do, right? But I can do something with the exponents, can't I?
If you do like the, you do like 1/3 times that.
Oh, well, hold on. What's 1/3 times 3?
Why?
Because that's the rule. Well, remember, your exponent rules, think PEMDAS. Parentheses, I can't do anything. Exponents, power to power, multiply.
Well, which pencils are you looking for?
The innermost.
Yeah.
So basically,
You
you
just
can't
do
just.
1/3.
You could, but you don't need to because you've got this right away.
Oh, that cancels it out, so it's gone.
Because 3 times a third is 1. So my exponents drop out. Are you okay with that?
Yes.
So now you wind up with this. 3 times x minus 1 over 3 plus 1. What's 3 divided by 3?
1.
Those go away.
Whoa! The -1 and the +1. This is too good to be true.
Works the same.
Watch, when it goes g of fx, it's just gonna go nowhere.
X minus 1
It's
plus
multiplying.
1 equals X.
But there's a minus sign.
You're multiplying because it's over 1. Fraction times fraction.
It equals X, by the way.
It works. So now, what's x minus 1 plus 1?
1, 0, X. Yeah.
It's more than 0x, I don't know! All right, so you get x on that first one. Go the other way. G of f of x. Start by writing down the f of x equation.
Let's do it.
3x cubed plus 1 over 3. Oh, thank you. Do that, because this goes in for x, so this is a minus 1. Yes. Sorry. No, I skipped a step, I'm sorry. Alright, sorry about that. What I've done here, all I did was write down f of x. You okay with that?
Yeah.
Alright. Now this goes to the x value in the numerator. Do you agree?
Oh, yeah.
So now I just have minus 1 all over 3 to the third. What's 1 minus 1?
0.
What's 3 divided by 3?
1. And then it's only the ones that are.
X cubed to the third.
It's x. It equals x. My hunch was right.
And Molly, in these questions, yes, because we're verifying that they are inverses. So they're telling you that they're going to be inverses to begin with, which means they better equal x. If they don't, you're screwing it up. Tomorrow, you're going to have to find the inverse. Tomorrow, you do this.
I don't want to see it until tomorrow.
If I wanted to find the inverse of that, all you have to do is, well, what's another name for f of x? Y equals, right? In order to find an inverse, all you do is you change x and y.
Y equals x. Yeah, that's so true.
And solve for y.
It's like y, baby.
There's the inverse.
Whoa.
You flip-flop x and y, and you resolve for y.
So you.
That's all it is. That's all it is for inverse functions. There are a couple extra rules here and there we'll look at about that, but it's really all that boils down to be is something that easy. Okay? Let me give you some problems. 7.3 and 7.4.
Yeah, it's gonna be like.
So 7.3 stuff is on page 418.
At least you didn't write 900 then.
Yes, these are units, correct.
At least you didn't write 900 then.
That's okay. Now this one here, that second group is that verify, and yes, they should both equal x if you do it correctly. If they don't, you did something wrong. On 7.4. Now the other part in 7.4, there is something that they talk about with domains. I'm going to hold off. Don't worry about stating domain for these problems for today. We're going to go into the domain and why it's important tomorrow. So don't worry about listing out any domains for tonight. One of the reasons that they have in the problems here where they're saying x is greater than or equal to 0 is because they don't want to look at any negative roots. So you might see where it says where x is greater than or equal to 0. It's not a big deal. Solving it out is not going to change it. Okay? Hey.
Well, you come down with.
All right.